Today we're starting 1.5, combining functions, shifting, and scaling graphs. This is all stuff that we did in Algebra 2 and pre-calculus, so we're still in the kind of the review phase here. So first, with functions, we can add two functions together. We can subtract them. We can find their products. And we can find their quotients. So we can add, subtract, multiply, and divide functions. So if I have f plus g of x, that just means I take the f of x function and add the g of x function to it. Same thing with subtraction, multiplication, and division. So if I start with f of x equals x plus 6, and I have g of x equals x squared plus 12x plus 36, if I do f plus g of x, then that means I'm just adding the two functions together. And I combine my like terms. So that's f of x plus g of x then combine our like terms. X and 12x adds to 13x. 6 and 36 adds to 42. So my final answer would be x squared plus 13x plus 42. If I subtract it, it's basically the same thing, but with subtraction. The only difference here is I have to remember to distribute my negative to all of the terms in g of x. So distribute that negative to each one of those. Give me x plus 6 minus x squared minus 12x minus 36. Combine our like terms again. I have negative x squared minus 11x, and then 6 minus 36 gives me negative 30. F times g of x. That tells me I do x plus 6 times x squared plus 12x plus 36. So I have to distribute each one of these first terms to each of the three terms. So x times x squared gives me x to the third. X times 12x gives me 12x squared. X times 36 gives me 36x. Now when I do the next part, I'm going to line it up. I'm going to do 6 times x squared, and that's a positive 6x squared, and I line it up directly under the x squared terms so I can combine my terms a little easier. 6 times 12, 72x, and 6 times 36 is 216. I'll just combine those terms. It's going to give me x to the third plus 18x squared plus 75x and then plus 216. And that's my final answer there. Last one would be f over g. I do x plus 6 over x squared plus 12x plus 36. I can factor this bottom out. It gives me x plus 6 over, and that's x plus 6 times x plus 6. So one of those cancels on the top and bottom. Gives me 1 over x plus 6. So now that I have an x in the denominator, I need to know what value would not work. So what value would give me a 0 in the denominator? And that would be negative 6, which tells me x cannot equal negative 6. Because I can't divide by 0. The problem with having you guys for the last like 3 years or whatever is that I can't tell my same Cookie Monster jokes from Siri. You know, it doesn't hit the same way that it did the first time. All right, the last type of combining functions is composite functions, and that's if f and g are functions, then the composite function f of g is defined by f of g of x. Means that we put g inside of f everywhere we see an x. And that's the domain of f of g consists of all the value x in the domain of g for which g of x lies in the domain of f. It's a really complicated way of saying that if I have like f of x equals 1 over x, then x can't be 0. So if g of x equals 0, then I can't use it at that spot. That's all that really says. So this is what we would call fog. And it's saying that we put the x into the g function, get a value out from that, and then whatever we get out of that goes into the f function. That's how f of g of x is made. Some functions are already composites, and we just didn't realize it. If we have a question like this, where we have the square root of 1 minus x squared, that's already a composite function. And it would be a function where if f of x equals, I could say that's the square root of x, and g of x is equal to the 1 minus x squared. So that now f of g of x, or f of g of x, equals putting the g inside the f for getting rid of this x value. If we learn to see this as composite functions, then we can find where this value is not going to work. So if I think about where a square root, what can a square root not be? I can't take the square root of a negative number. So I need to have 1 minus x squared be greater than or equal to 0. And I can find where my values would stop working. So I can subtract my 1 over. That'll give me negative x squared equals negative 1. Divide by negative 1. And I would get that x squared has to be less than or equal to 1. Take the square root. Still x has to be less than or equal to 1. Additionally, I would need my x to be greater than or equal to -1. So x is going to have to be in between these two values for this to work. G of f is the reverse of f of g. If it's g of f, that means that I'm putting the f function inside of the g function. So then we can work through multiple examples of this. If I do f of g of x, that means that I'm going to put the g inside the f. So square root of x plus 1. G of f of x means I put the square root of x in to the g function everywhere there's an x. So g of f of x equals square root of x plus 1. F of f means that I put whatever this value is inside another f of x. So it's going to be f of x equals, and that's the square root of the square root of x. And then g of g, I'll move that down some. G of x is equal to, I put an x plus 1 in for the x, and then it's still plus 1. So that one's just going to be x plus 2. If I think about the square root of x, remember the square root of x is x to the 1/2. So that's x to the 1/2 raised to the 1/2. When we have exponent inside of an exponent, it means that we multiply. So that's x to the 1/4, which is the same as the 4th root of x. So we can simplify some of these. Shifting a graph of a function. If it's a vertical shift, then I have y equals f of x plus k, with the k outside of the original function. And that means that if k is greater than 0, or a positive number, then it shifts the graph up. If k is less than 0, it's going to shift the graph down. For horizontal shifts, it will be inside the parentheses. And I have y equals f of x plus h. And if h is greater than 0, it shifts the graph to the left. If it's less than 0, it shifts it to the right. Some examples of these would be like my parent function being f of x equals x squared. Then this would be y equals x squared plus 4. That's taking the original function x squared and shifting it up 4. Y equals x squared minus 4, shifts it down 4. For a horizontal shift, if it's f of x equals x squared, then when it shifts left, it's going to be y equals x plus 4 squared. See the difference between horizontal and vertical is that my plus 4 stays inside the parentheses, and the 4 is actually getting squared as well. If it shifts to the right, it's got to be a negative. It's going to be y equals x minus 4 squared. Inside the parentheses and getting squared as well. Lastly, for today, we're just going to identify some graph shifts. So if the original one is x squared, what would x squared plus 1 be? It would be a vertical. Go ahead. Yeah. All right, so the first one is a vertical shift up 1. And this is a horizontal shift left 1. And that's it.